If we recall the definition of Laplace transform function f equals integral from 0 to plus infinity e to a negative st f of t dt. Because of the definition of Laplace transform, it has a lot of properties which are similar to the properties of integral. For example, the properties of Laplace transform. For example, if you take Laplace transform of sum of two functions, that equals Laplace transform of the first plus Laplace transform of second, because we can break that integral into two pieces. If we take Laplace transform of function multiplied by a constant, because again it's Laplace transform is integral, constant can go outside, so we can take constant c outside and take Laplace transform of f. For example, if you want to use that, Laplace transform of 6 equals to 6 Laplace transform of 1, which is 6 times 1 over s, which is 6 over s. Second example, Laplace transform of 3 minus t. So we're going to get Laplace transform of 3 minus Laplace transform of t. So we take 3 out, Laplace transform of 1 minus Laplace transform of t. So we're going to get 3 times 1 over s minus 1 over s squared. Because you recall, Laplace transform of 1 is 1 over s, and Laplace transform of t is 1 over s squared. We're going to write down Laplace transform of few elementary functions. Laplace transform of 1, we already discussed that, equals to 1 over s, and it's defined as long as s bigger than 0. Laplace transform of t equals 1 over s squared, and again s bigger than 0. In general, Laplace transform of t to n equals, if you try to follow the same pattern, but you notice that power of s will be 1 bigger than the power of t, and on top we're going to have n factorial, assuming that s bigger than 0. Domain is s bigger than 0. We also can find Laplace transform of sine and cosine functions. So Laplace transform of sine of b t equals to b over s squared plus b squared. S is positive. Laplace transform of cosine of b times t equals to s over s squared plus b squared. S is positive. And we already did Laplace transform of e to a t equals to 1 over s minus a, where domain of that Laplace transform is s bigger than a. If you want, we can try to apply both table Laplace transforms to find a couple of them. For example, Laplace transform of t squared, that is, we're applying Laplace transform of 2 to n equals to 2, so 2 factorial over s cubed, so 2 over s cubed. So here, when we have that Laplace transform of t to n, we're assuming that n is a whole number, n equals 1, 2, 3, and so on. whole positive number, so n is supposed to be natural number. Laplace transform, say, of sine of root of 3 times t is going to be equal to. So in our case, we're applying this formula, b equals root of 3 over root of 3 squared plus s squared, so we have root of 3 over 3 plus s squared. Few more Laplace transforms to memorize. So if you multiply t to n by e to the at, that Laplace transform equals, it's going to be similar to what we have here, but instead of s, we're going to have s minus a. And the main is going to be s bigger than a. So n factorial over s minus a to n plus 1. Laplace transform of e to at, say cosine of bt is going to be, again, it's going to be similar to what we have here. The only difference is going to be instead of s, we're going to have s minus a. S minus a over s minus a squared plus b squared, and the domain all as b. In similar fashion, we can define where Laplace transform of e to at times sine of bt. In this example, we want to find Laplace transform of f of t, which equals to 5 minus e to the 2t times plus 6t squared. So let's see how we're going to do it. So we'll write down Laplace transform of 5 minus e to the 2t plus 6t squared. We're going to break that into Laplace transform of smaller functions. So we're going to take Laplace transform of 5 minus Laplace transform of e to the 2t plus 6 Laplace transform of t squared. Laplace transform of 5, we take 5 out and take Laplace transform of 1. And Laplace transform of 1 is 1 over s. So we're going to get 5 times 1 over s. Recall what is Laplace transform of e to the 2t. It's going to be 1 over s minus 2 plus 6. And Laplace transform of t to n is, in our case, n equals to 2. So we're going to get 2 factorial on top, an extra power of s, 2 plus 1, 3 on the bottom. All that is left now is to simplify that expression. So we're going to have 5 over s minus 1 over s minus 2 plus 2 factorial is 2. 6 times 2 is 12 plus 12 over s cubed. And that is going to be Laplace transform of this polynomial. And that's going to be Laplace transform of this function. In the next example, we're asked to find Laplace transform of function f of t, which is e to a negative 2t times cosine of root 3 times t minus t squared e to 3t. So I'll find Laplace transform of each particular term here separately. E to a negative 2t cosine of root of 3t. So recall how to find the Laplace transform of this one. If we multiply by e to a negative e to at, so in this case a equals to 2 by cosine, so we're going to get s minus a on top, so s minus 2 times over s minus 2 squared plus b squared, which is root of 3 here. Recall what I'm doing is I'm using the formula that Laplace transform of e to at cosine of bt equals s minus a over s minus a squared plus b squared. That's a formula which we're using with a equals to -2, b equals to root of 3. So we're going to simplify that expression now. So we're going to get s plus 2 on top, s plus 2 squared plus 3 on the bottom. That was the first part. Second one, I'm going to find Laplace transform of second term. So Laplace transform of, I'll write down e to a 3t first, then multiply it by t squared. I'm going to rely on the formula which says how to find Laplace transform of e to the at times t to n. So that equals to n factorial over s minus a to n plus 1. So in our case, a equals to 3, n equals to 2. So let's put it here. So we're going to get n equals to 2, a equals to 3, a new power 2 plus 1, 2 plus 1 is going to be 3. And all that is left to find Laplace transform of this function, subtract Laplace transform t squared minus e to 3t from Laplace transform of the first term. So Laplace transform of e to the -2t cosine of root of 3t minus t squared e to 3t is going to be equal to s plus 2 over s plus 2 squared plus 3 minus 2, which is 2 factorial, 2, s minus 3